In this lesson, we're going to continue our deep dive into Mars by taking a closer look at the missions that were sent to Mars over the years. And just kind of see how those developed, how the technology improved, and how our picture of Mars, no pun intended, kept getting better and better. Actually, a pun was kind of intended there, I'm not going to lie. So the first mission we're going to look at, and I'm just going to kind of go chronologically. The first missions were these Mariner flyby missions of Mars. And I'm just going to pull up images as we go so you can see what these things look like. Flying. No, Mariner flyby of Mars. Ooh, this is a good one though. I want to keep this picture. So the trouble with a flyby mission, right? So this were what year we have here? 1968 it looks like. So the trouble 65. So these were satellites, right? So they had solar panels and stuff and a little dish to send the messages back to Earth, the pictures, and they had obviously a little telescope to take pictures. But now you gotta imagine, like, digital cameras didn't exist back then, right? So some of these very early ones even took film pictures and then were scanned on the satellite, and then those signals were sent back. So these were very rudimentary images. And when you have a flyby, it's not like you can keep taking pictures of the same area. I mean, you got one pass at this. And these cameras were not, like I said, not super sophisticated. So what you can see here is this is the path of the flyby, and you can see the pictures and the area that they cover, right? The square on the map of Mars represents the area it covers. So you have number 1, 2, 3, 4, 5, 6, 7, all the way up. And essentially it got 21 pictures of the surface of Mars. So imagine an entire mission to Mars. All it gets is these 21 pictures. So now we have the luxury of this entire map of Mars. We got to remove that from your mind. All you have are these drawings of Mars that have these gray splotches, and it's all you can really see. And along comes these Mariner pictures. Why is it showing planes? There we go. Okay, so look at these splotchy images, right? This is the first stuff that we get. Look at that. But what's seen in these pictures are very clearly craters. And when you see craters, here's some more pictures from Mariner of Mars. When you see craters like this, it tells you some stuff. One of the things it tells you is that there's really no atmosphere to speak of. Because if there was, there would be wind, there would be erosion, and these craters wouldn't just be everywhere. So this looks way more like the moon than it does the Earth. And if you don't have an atmosphere, then you don't really have vegetation or life of any kind, because there's no mechanism, right, for fluid to be cycled, like water to be cycled through the atmosphere, for air to come in and out. And so what's striking is that simply these observations of these preserved craters was enough to basically tell scientists that Mars is a dead planet, which is really quite striking. So the Mariner images, while they don't show us a lot, they tell us a lot, which is pretty cool. Now the next missions were this huge leap forward, and that is the Viking missions. Now these were missions that were, again, I believe, flyby missions. They weren't orbiters. But what was particularly important about the Viking missions is that they included landers. So this is a picture of what these things looked like. Okay, so it was a lander that would just bump. All right, and so the whole point was to see what things look like on the actual surface of the planet. So amazing step in technology and what we're able to see. Right, this is our old pal Carl Sagan next to a model of the, or probably a test used for Viking landers. But these are the kind of images we see from the Viking landers. I mean, if I showed you this picture and I asked you what decade these images were taken in, my guess is you would not, and I told you it was Mars, my guess is you wouldn't say the 70s. Okay? These are incredible images captured from the surface of Mars. Now, some of these have been, like, the colors can be kind of tweaked a bit, but this will give you a pretty realistic sense of what, this one in particular, of what it would look like on Mars. The sky is not blue, kind of has this yellowish, pinkish kind of color to it. Here's some other images that maybe are a little closer to what our eyes would see. Okay, really amazing pictures. And I want to dwell on this for just a second, because when I was a young student, when I was like a teenager, I've shared this was one of the first books I read about astronomy by Carl Sagan here, Cosmos. And one of the reasons this book was so amazing to me is it was just full of these cool illustrations. But, I was a teenager in the mid-90s, okay? Now, that might seem like a long time ago to you, but it wasn't that long ago, right? I mean, you guys were probably born in, like, the thousands. The mid-90s wasn't that long ago. And these Viking images were actually some of the best pictures we had of the surface of Mars. Look at that. I remember seeing these pictures as a young student and being like, what? Oops, this is an old book. There goes half of it. These are pictures of the surface of Mars, and it just kind of blew my mind seeing these in here. I just want to show you because, like, it's easy for us to take for granted that I can just, like, type these things in on the fly into Google and we can see all these amazing pictures. This was my exposure to those, and what for me really ignited that interest in space. Okay, the Viking missions, really cool, really incredible. What's striking is there are no missions really to speak of that went to Mars throughout the 1980s. And we should understand why that is, right? Because we know that that was the heyday of space shuttle mania in the United States, right? That's when the shuttle was really the focus of the U.S. space program. So we don't see missions to Mars during that time. And the missions to Mars then pick back up in the 90s. But what happened in the 90s was really a number of catastrophic failures. So we have 3 missions in particular. Mars Observer, and there's probably not going to be anything to see here. The Mars Observer, we can just see what these spacecraft look like. The Mars Climate Observer, and the Mars Polar Lander. Now, all 3 of these spacecraft did not successfully reach their target on Mars, either orbit or landing, and for various reasons. A loss of signal. In one case, it was a unit conversion problem where one developer was using like centimeters, the other was using inches, and so it just crashed right into the planet. Okay, so not good things. When you spend hundreds of millions of dollars on a mission to Mars and it gets there and crashes, like that's a huge setback for ongoing funding as well as for the scientists who are doing that work. But all of that changed with the Pathfinder, Mars Pathfinder. And I remember this when this happened. It was so cool. It was the first rover on Mars. Now I've got to find the video of how this worked because it was so extraordinary. This is what the rover looked like. And when you see this, when I first thought and when this was happening, I'm thinking, oh man, look at this giant rover going around on the surface of Mars. This thing is like a RC car, okay? It's like tiny, and it's got this little camera. What was so cool about the Mars lander, I think what captured a lot of people's excitement, was how the Pathfinder actually landed and arrived safely on Mars. So let me just show Pathfinder landing. What was so cool about this, and all right, so as this thing is approaching, parachute slowing everything down, but the issue is how do you really, this thing's traveling insanely fast on its way to Mars, right? So how do you actually get it to land softly on this other planet, and especially when there's very little atmosphere on Mars? So check this out. This thing is like tetrahedral thing. Watch what happens. Wait for it. Wait for it. Slowing down. And when's it gonna happen? When's it gonna happen? Airbags! Who would have thunk it? Okay, retrojet fires, release and it bounces. Can you believe this? They take this rover lander and they let it like bounce on the surface of Mars. This literally happened. This isn't science fiction. This is what we did to land our first rover on Mars. Okay, it rolls and rolls and bounces until it eventually stops. And then it kind of orients itself the right way, deflates, unfolds, and then reveals the tiny little robot who kind of itself then unfolds. Okay, and that's our old pal. Oh wait, I got the wrong one. This is Spirit and Opportunity. Dude, I'm totally off. Okay, so this is the next. Oh man, I totally messed up. Yeah. They're the same. So this is So this video, so I totally just got confused, right? So this video was showing the rover of Spirit and Opportunity inside, but the same technique of balancing the airbags is what was used for Pathfinder as well. So even though this is the wrong rover, it's the right process. So this is an effective way, apparently, of landing a rover on the red planet. Now, in addition to these, I got to show you pictures. So Pathfinder takes these pictures, right? And these are the first pictures in over 20 years from the surface of Mars. Coming down in the late 90s, and of course this thing can drive around. So now we can start exploring the surface of Mars. And here are pictures from the Pathfinder. Okay, so incredible photos, tons more photos than we got from Viking, and of course the ability to go drive up to a rock and like drill a little bit of the rock and see what's going on. Yeah, you're wondering like, well, how do we get a picture of the rover? Like, who took that picture? Well, there's cameras on the actual lander itself. Amazing photos, probably thousands of photos that came back from this spacecraft. Okay, so then what's next? We got more and more sophisticated orbiters. So you kind of see this pattern going by. We had flybys, you've got orbiters around Mars, and then you've got landers. So one of the most successful missions ever was the Mars Global Surveyor. This was, I believe, really the first orbital observatory of Mars. And it captured just an amazing wealth of data. In fact, it operated, I think, for over a decade collecting data. Maybe continues to. I don't think it still does, but collects all kinds of, mapped out basically the whole surface of Mars in incredible detail. All right, so these are pictures from Mars Global Surveyor. You can see this is a great example of how having an orbiting satellite can allow you to see how things change on the surface of the planet. So here's like a crater's edge, and you can see here's a picture of this same spot 2001 and 2005, and you see how it has new features, right? So like, is that ice? Is that like a little melted ice that broke free from underneath and now is flowing again, right? In this temporary period of time, is it like a mineral deposit that was let loose? So the point is, you can see these changes, and then geologists who are studying Mars can use those comparisons to understand how the surface of Mars is continually changing. Okay. Then we've got the Mars. Let's do Spirit and Opportunity. So Spirit and Opportunity. I wonder if you guys actually like remember this. You know, it feels like it wasn't that long ago. But this is a case where after the success of the Pathfinder lander and rover, they realized that if we send one rover, we might as well send two. I mean, all the cost of developing a whole new rover, all the technology that goes along with it, when the second one is like half price when you're building two of them. So they sent two to two different places on Mars simultaneously, right? So these two rovers are like tooling around the planet. This is what they looked like. So they had like a mast cam up high with two cameras so you can get stereoscopic pictures. It had like a little drill hand here you can see with like tools to like, it was actually like a little laser shooter so it could like burn up a little piece of rock and take spectra of it. So these rovers get more and more sophisticated. They're able to carry more instruments and do more scientific experiments. Now these, I wonder if we can have a sense of scale for how big this is. There you go. Okay, here's a small child standing next to it. So it's, you know, it's not the size of a car, but it's still reasonably large. And you can just see how it's like a scaled up version of the Pathfinder lander. Now, in our previous course, we played around with Google Mars. And so what's fun is to take a look at that, and we can actually see then where these spacecraft have landed. So here we have Viking 1 and 2's locations, and then we have MER, Spirit, and Opportunity. So here's Spirit's landing spot. Let's see if we can... the Spirit rover. It's right there. By the way, this this elevation data, all this color data here, which is showing like the elevation of Mars, that was from a laser altimeter carried on board the Mars Global Surveyor, right? So one of the things that it did is it mapped out the precise elevation of the entire planet. So a lot of this data that we look at here from on Google Mars is actually coming from the Mars Global Surveyor, that really successful orbiting satellite. Okay, so here's where it landed. I wonder if it shows us any more detail. If you use Google Earth, you can like see the exact path. You can see where the pictures were taken, all that kind of stuff. So let's just pull up Spirit rover. Now, of course, as these two rovers were cruising along and doing their thing, here's some nice pictures. One of the rovers, unfortunately, got stuck in the dirt. I had a chance to observe this personally at JPL, the Jet Propulsion Lab, right? And so one of the rovers, undoubtedly what happens is the rovers, they get covered with dust. When a dust storm comes through, they lose some of their ability to charge from solar panels. But eventually got caught in this fine dust. And so these things are being like controlled by controllers back here on Earth who are programming each day. They're like, okay, drive forward, 10 meters and then go to the right and take 10 pictures, all that kind of stuff. Well, when it's not moving, it gets stuck. What they did is they recreated the exact conditions, like the tilt, the quality of the material it's at. And so when I had a chance to visit the Jet Propulsion Lab, I got to see exactly this setup, right? There was like a handful of scientists standing around, and they were all like measuring all this stuff, all right? They were just like standing around. In fact, I remember that dude. That dude was there, all right? And now this was like 5-6 years ago, right? And they're measuring all this stuff. And the best part, this dude had like a big red button, all right? And so then they're all sitting around and they all gather. And we were only there for like 5 minutes. And then the guy pushes the button and like the wheel turns a little bit and nothing happens, right? So I felt like we witnessed this amazing moment because the woman who was giving us the tour said, usually they're just measuring things. They're not like revving the engine to try to get it out. So the point is, I don't know what the point is. It's just really cool. I guess that's the point. Okay, so the Spirit and Opportunity. And then the Mars Phoenix lander. All right, so Phoenix lander. So this was, again, in the past, this was like the 2008 and 10 is where we're getting at now. Here we go. All right, so the Phoenix lander was, we've had all these rovers, right, which are really complex. They're hard to build, they're expensive, and they have to drive around and they last a really long time. The purpose of the Phoenix lander was to say, let's lower our scope a little bit, lower our cost. Let's have a thing which just lands, doesn't drive around, but it digs beneath the surface. Because we're starting to see evidence from Mars Global Surveyor and some of these other orbiters that there's ice beneath the surface which appears to be like broken free sometimes. So as we see all this evidence for liquid water having flowed on the surface of Mars, the question becomes, could there still be liquid water in the form of ice that melts and then like breaks free? So what they realize is these rovers are great. They can dig little like rock laser things, but none of them actually try to dig beneath the surface. So what would we discover if we built a lander that actually just had like a big digging arm? And that was like what it did, is it dug and took pictures and spectrum and all that. So here's what the Phoenix lander, that's not a great picture, what the Phoenix lander kind of looked like. And let's get a picture of what it saw. Here we go. Ice. What it saw is this is great. Look, it just dug a bunch of holes, right? It like couldn't move anywhere. It just kept digging. I love it. All right, and so it would dig these holes, and what it saw is just beneath the surface was like a permafrost, like a layer of ice. And what's particularly interesting to see is that over time, that ice would like evaporate. We call that sublimation, where ice turns to a gas directly. So you can see it's like carved spot here. A lump of ice is in the shade right there, and then a few days later, that ice is gone. Right, so we're seeing changes right in front of this spacecraft. Now, again, that's something you might expect if you have very low atmosphere. And the thinking is here that if you have a source of warmth underneath the surface of Mars that melts a huge bit of this ice, and it kind of builds up pressure like an ice dam, and then breaks free, you could have like a gush of water across the surface, and that might be something that we would see. Okay, that's the Phoenix lander. All right, the last one that I've been really excited to show you. Well, I guess it's not the last one. Okay. The one I'm really excited to show you, though, is the Mars Reconnaissance Orbiter. So the Mars Reconnaissance Orbiter is kind of like the follow-up to the Mars Global Surveyor. This is an orbiter that's like, again, a spy satellite taking pictures of the surface of Mars and just captures the most astounding photographs. So these are all real pictures from this satellite of the surface of Mars. This one blows my mind because it almost looks like these like lines. They look like stands of trees to me. Of course they're not, but there's dark lines in the sand. So these are the sand dunes. Got these incredible images of craters. Look at this. You can see like this. It's like clearly there's liquid that has flowed on these edges. I mean, it looks like a river. This looks like a picture of Earth that you would expect to see, but this is on Mars. This is another favorite, a crater that has almost like sand dunes. So I live near Lake Michigan, and you see this kind of these kind of features in the sand under the water. But wind can cause these similar kind of striations. I showed you before this real picture of a landslide in process that was captured by the Mars Reconnaissance Orbiter. It also has captured pictures of little tornadoes in process. So this is like it's called a dust devil, like a little mini tornado from the MRO. Absolutely incredible. In fact, here's even a photo of the rover, the Curiosity rover. Now I have to show you my favorite photograph. Like, this is what I've been excited about showing you the entire time. So this is, to me, one of the most amazing photos ever captured anywhere, and that is right here. So the most recent spacecraft to go to Mars, the most recent like rover we've sent, is a Curiosity rover, which we'll look at in just a second. But on its way down, so Mars Reconnaissance Orbiter was already there taking pictures, and in fact served as an important communications relay. But as it was there, they arranged things so that this orbiter could be over the rover as it was descending. And so in fact, we have a photograph of this rover and the parachute while they are in descent to the surface of Mars. So we have one of our spacecraft photographing another one of our spacecraft, a rover. It's just mind-boggling to me. I wonder if there are other ones that are similar here. This looks like it's after it. Oh no, this is an ancient Egyptian empire apparently on Mars. I don't think so. All right, so pretty cool. In fact, this looks like this is where, yeah, this is the descent stage crash site. Yes, so they can actually see where it was descending, where the rocket engine that was slowing it down then crashed on Mars. We're littering the solar system with our junk. There's no doubt about it. Oh, dude, check this out. So here's like the crash site, and there's there's the parachute that's all flapping in the wind. Oh man, this is crazy. All right, so truly incredible the kind of detail we're able to capture. All right, and then the last spacecraft is the Mars Science Lab, which is called the Curiosity rover. And this is much larger than any of the previous rovers. It looks something like this. It's roughly, I wonder if there's like a nice real photograph of it. Oh, here you go. It took a selfie. This was it set up its camera and like held up its camera arm and took a picture of itself. So this is the actual rover on Mars. Like the others, it has like a mast camera. You can see all the different crazy tools it has on board. Again, it has ways of like lasering rocks and taking spectra of it. Captures all sorts of pictures. The Mars Science Lab images. Let's see some of its photos of the surface. Curiosity rover images. Here we go. So again, quite amazing, these views from the planet. It's like having a robot geologist driving around, learning about Mars. The point of showing all this is less about the science that's being discovered by these missions and more just about the evolution of missions. Now think where we started with these Mariner flybys where all we could really see are craters. And now here we are where we can capture photos of rovers while they're descending and have them drive around with this insane set of tools, studying the planet just like a geologist would if they were walking around. Truly incredible. I hope you had fun with this. Sorry I was a little loosey-goosey, but hopefully fun nonetheless. All right. We'll see you next time.